one, I want to give everybody on the panel their chance to basically talk through what they've learned and their statements. So why don't we go ahead and start with Space Rogue.
I thought you were going to start in the middle, but that's okay. So my name's Space Rogue. 20 years ago, out of fear of corporate retaliation and through lawsuits mostly, Space Rogue was pretty much the only name that I used, right? Today, I also use the name Chris Thomas, although not as frequently, and I work as the global strategy lead for IBM's X-Force Red, which is the offensive security services part of IBM Security. Today, we're going to talk about how things have changed in information security over the last 20 years. When we were here 20 years ago, a lot of people said we were a voice of reason, attempting to warn people about just how much risk was inherent in our critical systems. A lot of people in information security, or I guess we call it cybersecurity now, that's one thing that's changed right there, will tell you that nothing has changed, that we still have issues with passwords, from password reuse to weak passwords to no passwords. We still have organizations who ignore the problems, either through ignorance, ambivalence, or just greed, and we still have people who try to blame users for technological failures. When I was here 20 years ago, I talked about and touched on a lot of different topics. I talked about the weakness in access control cards. I talked about software liability. I talked about the rise of nation-state attackers. And I talked about the lack of authentication and ease in jamming GPS signals. I also mentioned that the goal of information or cybersecurity should not be to make something 100% secure, because I still don't believe such a system is possible. 20 years ago, the possibility of cloning an access control card to gain entry into a building was a known risk, but was considered to be so difficult that no one would do it, and it was an acceptable risk. Cloning access cards today is much easier, but attackers still most likely will just sneak in behind someone else or tailgate them, because that's even easier. Software liability was a concept that was seldom even thought about 20 years ago. Today, the increase in software in all sorts of devices, from self-driving cars to medical devices, and the issue of liability of who is ultimately responsible for bad code that can actually kill people, is being weighed out in our courts. Over the last 20 years, nation-state attackers have become the predominant threat for many organizations, something that was almost unheard of 20 years ago. The nation-state threat is more than just compromising networks and endpoints. Today, it focuses on much more on information gathering, disinformation, and just plain old propaganda. You can look no further than the evening news every night right now to see examples of that. GPS has become critical to our way of life, and yet the risks remain the same. We now depend on GPS not only for flight navigation, but for personal car navigation. GPS is also used by emergency services to locate a phone from someone who may be in distress. Military applications of GPS have received some improvements, especially with the recent introduction of M code into the GPS architecture. But risks through signal spoofing and authentication controls remain. However, it's not all doom and gloom. Some things have changed for the better. Today, we have a lot more information available to us, if we want it. We have greater ability to inventory not only our endpoints, but what exactly is running on our networks. We can know with certainty what our critical data is and where it lives. We can analyze traffic with more speed and precision with much lower costs than we could just a few years ago. This visibility into our infrastructure is critical in identifying and eliminating risk. Once we know what systems we have in place, where our data lives, then we can prioritize our remediation efforts. We can deploy our scarce resources into making our systems more resilient in an effective way. Instead of just applying fixes or new defenses in some random fashion, we have the information available to us today, if we choose to gather it, to make educated decisions about how best to apply our limited resources. And once those resources have been deployed, we can then shore up our defenses. We have the ability to test our implementations, both manually and with automated tools, and that ability is continuously improving. Testing our defenses, whether through code review, penetration testing, red teaming, or other methods, is just as important as deploying our defenses in the first place. Our testing abilities, knowing what to test and how to replicate real-world attacks, gets better every day. We've learned a lot of lessons over the last 20 years. For example, we know that flat networks are not a very good idea. We know that segmentation and compartmentalization when it comes to network design makes things much more difficult for an attacker when they are deployed correctly. We have learned that using strong encryption whenever feasible is a really good idea, and that while strong encryption still isn't always easy, it's a lot better and more prevalent than it was even 10 years ago. And we have learned that using multi-factor authentication whenever possible makes an attacker's life that much more difficult. Even when the implementation of those other factors may have weaknesses themselves, anything in addition to a simple password makes the attacker's job just that much harder. And while network design, encryption, multi-factor authentication are not necessarily new things, they all existed for a lot longer than 20 years, they have become much more ubiquitous in today's environment and have gone a long way in making the world a more secure place. The government has learned as well. Look at the NIST cybersecurity framework, which is a policy framework developed by a wide range of people involved in cybersecurity from both the public and the private sector working together. The framework helps organizations of all types assess their environment and use that knowledge to be proactive about risk management. Such advanced thinking from government about information security was pretty much hard to find 20 years ago. Our problem today isn't so much that we don't know how to make things more secure, it's that we're not applying that knowledge evenly. For every organization that implements multi-factor authentication, there's another one that is running old, outdated, and unpatched operating systems. For every organization that is properly encrypting all its data, there's another one that isn't and has a web-facing database vulnerable to SQLI. For every organization has limited resources, but today we can have a lot more information available to us that allows us to deploy those resources appropriately. We know we have greater ability to test those deployments to ensure they are installed correctly, and we now have technologies and policies that make an attacker's job much more difficult. And so while we can't ever make something 100% secure, hopefully over the next 20 years we can use the knowledge we already have and the knowledge that we will gain to create a much more secure world for everyone.
Thank you so much, Space Rogue.
No problem.
So before I move to the next, our next STAR LOpht member panelist, I want to highlight the fact that 20 years later, we're still talking about some of the same threats. We're just talking about the defensive side of what we've learned in these 20 years. And notably, every single one of us up here are former at stake, where I believe one of our very honest marketing ads said, "You will never be 100% secure." That's always going to be true. So with that, take it away, Weld.
There we go. Hi, my name's L0pht, or I mostly go by Chris Weisopel. That's how I know if someone really knows me from way back. They call me Weld. My job right now is I'm the CTO and co-founder of CA Veracode. I started Veracode in 2006 with Christian Ryu, also known as Dildog, another LOpht member, and we started it to help make software more secure, and took a lot of the learnings from my early days at the LOpht into doing that. But back in 1998, we were outsiders. We were curious people learning about the systems out there that we used every day, Windows 95. And we wanted to understand how network and technology worked, and we found problems along the way as we explored. So I think the root of being a hacker is exploring, and that's really how we got started. But we found problems, and what do you do when you find a problem, right? The right thing to do is to help other people who have that problem. So we started off thinking we were going to help users. We're going to help users and of technology become aware of these problems. And in course of doing that, we started making the vendors that made the technology pretty upset. And I think that's how we originally got our notoriety, was pointing out really that the emperor had no clothes, that no one was making secure systems back then, and we were discovering really huge gaping holes in the systems that people were using. And we were using our outsider attacker perspective to do that, something that the vendors didn't know how to do. They couldn't, you can't be a critic of yourself. It's very hard to do that. So that's when we started to realize that this outsider view, adversarial view, critic view was something that was actually absolutely critical to building secure systems, and it had to become part of the way we thought about security. And so we started to move slowly from, with that perspective, moving to actually start to work with vendors. There was one day Microsoft sent us an email and said, you know, guys,